All right, so for this section, this is a bunch of word problems. So I have this doc posted on the assignments page under section 2.4 as well as in the file section. So if you just want to print this out and fill it out like I'm doing, you can do that, or you can write these all down. I just don't want to take too much time writing out these word problems. So first things first, since this is a bunch of application problems, let's go through the steps that you should generally follow to solve these. The first one seems kind of obvious, but it's really important that you read and understand the problem before you get started on anything. So we want to know what kind of information we're given. And we want to figure out what we're looking for. And so figuring out what you're looking for is really important for this next step because we want to define a variable. And so what this means is we want to know what x or whatever variable you're using is going to represent. So we're going to have x equals some quantity or some unknown that we're looking for. Once you have that, we can go ahead and write an equation. And since these are all one variable linear equations, you should only have one equation. We'll get to two equations a little bit later in a later chapter. Once you have the equation written, we can go ahead and solve it. Once you've solved that, then we can state the answer. And this part's important because since they're application problems, you don't just want to leave your answer as x equals whatever number you got because it represents something. And so this is where defining a variable is helpful, especially when we get to ones with two variables. You don't want to mix them up. And you want to include any units that the answer might require. So if we're trying to find a distance, it might be miles. So keep that in mind as you're going through. And then you want to check your answer in the original problem. Just to make sure that it makes sense. And so we'll see what that looks like when we start looking at some of these examples. All right, so on this program I'm using, I have to go ahead and clear all of these. So if you need a second to write them down, I'll just pause the video. And then let's go ahead and look at the first example. So this first example here says if 5 is added to a number, the result is 7 less than 3 times the number. Find the number. So they give us this information up here. This is our given information, and they want us to find the number. And so these ones, defining the variable isn't as important, but it's still something you have to do. So I'm just going to say x equals the number. That's what we're looking for. And so now we can set up our equation. This is where those other problems that we've done come into play. So this says if 5 is added to a number, so that means we have some number which we called x, and we're adding 5 to it. So x plus 5 or 5 plus x, addition, the order doesn't matter. The result is, this is our equals. So remember, it separates the left side from the right side. 7 less than 3 times the number. So think multiplication comes first. So 3 times the number is 3x. And we want 7 less than that. So we want, if this were 10 and we wanted 7 less than 10, we would have to subtract 7 from 10. So now we're going to take 3x and subtract 7. And now we have our equation. We have 5 plus x equals 3x minus 7. And now this is just like the equations we were just solving. So let's go ahead and get the variables on the left, the constants on the right. So I'll subtract 3x. or if you want to move the variables to the right, that's fine too. So we have a 5. 1 minus 3 is negative 2x equals negative 7. 5 needs to move to the right, so we'll subtract 5. And so we're left with negative 2x equals negative 7 minus 5 is negative 12. And if we go ahead and divide both sides by negative 2, then we get x equals positive 6. So I'm not going to box this as our answer because we want to actually state the answer, and you can do it using a sentence or just a phrase. It depends on the problem. This one I'm going to write out a sentence because the answer can't just be stated as 6, whatever the units are, because there are no units for this one. So I'm just going to say the number is 6. And you can take this, plug it back into your equation. Think about it in the terms of the original sentence here. So if 5 is added to a number, so if we add 5 to 6, we get 11. The result is 7 less than 3 times the number. Well, 3 times the number is 21. And then if we take 7 less than 21, that's going to give us 5 is added to a number. Let me double check the work over here for this one. So let's see, we subtracted, we got a negative 2, we subtracted 5. Oh, that's why, our number is 6. Okay, sorry, our number is 6, so 3 times the number is actually 18. And then 7 less than 18 is 11. So this one's good. All right, sorry about that. I messed up our number there, but we still got the right answer. All right, let's go ahead and take a look at number 2. So number 2, pretty similar. It's not quite an application problem yet. We're told the product of 9 and 4 more than twice the number. Notice how there's parentheses here, kind of separating that as its own group. Is 15 less than the number. Find the number. So again, we're looking for the number. I'll just say x equals the number. And so let's find our equal sign first. So we have is right here. The right side's a little bit easier. 15 less than the number. We have 15 less than something. We need to subtract 15. So x minus 15. And then on the left, we have the product. Remember, this means multiplication of 9 and 4 more than twice the number. So this here is telling us that this needs to be grouped because of these commas here. So 4 more than twice the number. 4 more means we need to add 4. Twice the number is going to be 2x. So we need to have 2x plus 4. And we want the product of this and 9. So product means we're multiplying 2x plus 4 by 9. So we have our equation here. We have 9 times 2x plus 4 equals x minus 15. And now if we go ahead and start solving this, we want to distribute first. So 9 times 2x is 18x. Plus 9 times 4 is 36, equals x minus 15. I'll go ahead and move all the variables to the left first, so I'll subtract x. 18x minus 1x is 17x, plus 36, equals negative 15. Let's move this 36 over. So if we subtract 36, they're the same sign. So we want to actually add these, and it's still negative. So we get 51, negative 51, and then divide both sides by 17. And 17 is going to go into 51 evenly. It goes in 3 times. So x equals negative 3. So again, we're not going to box this. We're going to write our solution as a sentence. So we'll say the number is negative 3. All right, now let's go ahead and take a look at some more application-based problems. So this first one here, we're talking about legislatures. And so we have a 150-member Iowa legislature, which includes 12 fewer Democrats than Republicans. And there are no other parties represented. And we want to know how many Democrats and Republicans there are in the legislature. So this one, we'll see problems like this later where we have 2 variables because we have Democrats and Republicans. But for now, we're just working with 1 variable. And so we want to figure out which one we want to define our variable as. And so it doesn't matter which you pick. It depends how we interpret this first part here. So we have 12 fewer Democrats than Republicans. So let's just say we had 50 Republicans. If we had 12 fewer Democrats, then we would need to take the number of Republicans and subtract 12. So what I'm going to do is I'm going to say that R is the number of Republicans. And then our Democrats, this isn't really a definition, it's going to be our expression. The Democrats is the number of Republicans minus 12. So it's going to be R minus 12. So now let's go ahead and set up our equation. So what we do know, our other piece of given information is that we have 150 members altogether. So if we take the number of Republicans R and add the number of Democrats, which we could put D, but that's not going to help us with 2 variables. We want 1 variable, so let's use R minus 12, should equal 150. So again, that's usually the hardest part. Now we need to go through and solve this. So let's combine like terms. 1R plus 1R is 2R, minus 12 equals 150. Let's add this 12 over to the right. So we get 2R equals 162. And then divide both sides by 2. So we get R equals half of 162 is 81. So this is one where it's really important that you fully answer the question and don't leave it as just R equals 81. We wanted to know how many Democrats and Republicans. We know that there are 81 Republicans. And so this one, I'm not going to write this out as a sentence. I'll just put how many we have of each. And the Democrats, well, we know there's 12 fewer Democrats than Republicans. So we know we need to subtract 12 in order to find the number of Democrats. And we can use this equation up here to figure it out. So it's the number of Republicans, which is 81, minus 12, subtract 10, we get 71, subtract 2 more, and we get 69. All right, let's try another of these. All right. At the 2014 Winter Olympics, Germany won 10 more medals than China. The 2 countries won a total of 28 medals. How many medals did each country win? So this is another one that's pretty similar to the one we just did. They're giving us a total amount, so we know we're going to be adding the two amounts together, but we need to come up with an expression for Germany, that's one of our unknowns, and China. So again, Germany won 10 more medals than China. So if we said that China won 20 medals, Germany won, that's China, Germany won 10 more. And so in order to find how many Germany won, we would need to add 10 to this. So for Germany, put a line there because we're not multiplying these. We're taking the number that China has and then adding 10. So I'm going to say that C is the number of medals China won. And then Germany will write in terms of the amount that China won. So Germany is going to be the number that China won plus 10 more. So here's our variable definition. And so now our equation, they have a total of 28. So if we have, if we add these two together, so the number that China won plus the number that Germany won in terms of C plus 10, we should get 28. So now let's solve this. Let's combine like terms. So 1C plus 1C is 2C plus 10 equals 28. Then we want to subtract 10 from both sides. So we get 2C equals 18. Divide both sides by 2, and we get C equals 9. All right, so again, they want to know how many medals each country won. So we want to write down our answers for Germany and China. So China, we know, won 9 medals. Medals is our units. Germany won 10 more. So Germany is the number that China won plus 10 more. So Germany won 19 medals. And then always double check that this makes sense. So we know Germany won 10 more. That's what we have here. And the other piece of information we were given was that it's a total of 28. If we add these together, we get 28. All right, let's take a look at some more examples. Number 5, a piece of pipe is 50 inches long. It is cut into 3 pieces. The longest piece is 10 inches longer than the middle-sized piece, and the shortest piece measures 5 inches less than the middle-sized piece. Find the lengths of the 3 pieces. So for ones like this, where you're given a piece of pipe or a piece of wood, plank of wood, I like to draw out diagrams for these, and this is your other option for defining your variables. Not sure if this is something they'll give you on MyMathLab, but if you ever get doing one of these tests in person, something like this in Math 96 or 120, you can do it like this. So we know we have a long piece, a middle-sized piece, and a short piece. So I'll make this one short, middle, and long. So I'll just put short, middle, long. So we have that. We know the longest piece is 10 inches longer than the middle piece. And we know that the shortest piece is 5 inches less than the middle piece. So if you notice for this one, we're comparing both of these pieces to the middle-sized piece. There's a lot of problems like this where you're comparing multiple things to one other quantity. And so since we're comparing both of them to the middle-sized piece, it's easiest to label that piece as your variable. So let's go ahead and label our middle-sized piece as, I'll label it M. And now we know the longest piece is 10 inches longer. So if it's longer, we're going to be adding 10. So it's going to be our middle-sized piece plus 10. And the shortest piece is 5 inches less. So we're going to take our middle piece and subtract 5. So this is our diagram here. You can also define it by saying m equals the length of the middle piece. That's kind of the more formal way of defining this. We know that this entire piece of pipe here is 50 inches long. So that means that all three of these pieces need to add up to 50. So we have m minus 5 plus m plus m plus 10 equals 50. And then we can go ahead and solve this one. Simplify first. So let's combine the m's, and then we'll combine the constants. 1m plus 1m plus 1m is 3m. Negative 5 plus 10 is positive 5. And then we'll move that 5 over to the right, so subtract 5. And we get 3m equals 45. Divide both sides by 3, and we get m equals 15. That's not our final answer. We wanted the length of all three pieces. So we want the length of the short piece, the middle piece, and the long piece. Make sure you're labeling the lengths here. We want to know which one's short, middle, and long. So the middle one we know is 15, and we want to include the unit, so it's 15 inches. The short piece we have as m minus 5 because it's 5 inches shorter. And so for this one, we're going to take our middle piece, m 15 minus 5, which gives us 10 inches. And then our long piece is the middle piece plus 10 more. So that's going to give us 25 inches. All right. Next example. We just have a few more here. So number 6, 2 pages that face each other in a book have a sum of 569. Well, what are the page numbers? So first, reading this seems a little tricky to figure out how we could figure out what the 2 page numbers are if they have a sum of 569. But if you think of a book, oops. Beautiful drawing of a book here. If we said that the left side of this was page 20, the right side is 1 page later, so it's 21. We don't know what our page numbers are, so if I call the left side x, then the right side is 1 more, so it's going to be x plus 1. So I'm going to say that the x is equal to the left page. And then we know our right page is x plus 1. And when we add the 2 pages together, we should get a sum of 569. So that means x plus 1 equals 569. And now if we go ahead and simplify, x plus x, 1x plus 1x equals 2x, plus 1 equals 569. Subtract 1, so we get 2x equals 568. And then divide both sides by 2. So half of 568, half of 500 is 250, half of 60 is 30, so that's 2 80, and then half of 8 is 4, so 284. And again, this is not our final answer. We want to know the 2 page numbers. So I'll write our answer as left page and right page. Our left page was X, and so our left page has to be 284. There's no units on page numbers. And the right page is just going to be one more than that, so it's going to be 284 plus 1, so 285. All right, this next example is a really important one, so I'm going to star this one. This is one that comes up a lot. It'll show up now. It'll show up again when we're looking at 2 variable questions. So we're told the sum of 2 consecutive even numbers or even integers is 254. Find the integers. And so we have 2 consecutive even integers. So just to think about what that means, we'll look at this with real numbers first. Even numbers like 2, 4, 6, 8. Integers means they're whole numbers, and they're consecutive, so they're one after the other, but they're even. So 2 consecutive even integers, something like 2 and 4. You'll also see other examples where they're 2 consecutive odd integers, like we have down here, so that'll be something like 1 and 3. Or just 2 consecutive integers, which would be something like 1 and 2, because they're not necessarily even or odd. All right, but we want to know what these are that add up to 254, because these are nowhere near there. And so we can go ahead and use x's. So I'm going to say that the first integer is x. That's our first integer. And then we need to think about how we can get from the first to the second. So since we're talking about even numbers, and it'll be the same with odd in a second, we have to add 2. Make sure you don't multiply by 2. If we'd picked 4 and 6 instead, you can't multiply by 2. You still have to add 2. And so our second integer is going to be x plus 2. And you don't have to formally define that one. I'm just going to write it down here. Okay, so now we know the sum of them is 254. So if we add these 2 expressions, we should get 254. So x plus 2 equals 254. Combine like terms, 1x plus 1x is 2x, plus 2 equals 254. Get our constants on the right, so we'll subtract 2. So we get 2x equals 252. And divide both sides by 2. And so half of 252, half of 200 is 100, half of 50 is 25. So we have 125 plus 1 more for half of 2, so 126. And we wanted to know what the 2 integers were, so I'll say the first integer and the second integer. The first integer we got right here is 126. The second integer, we know they're consecutive even integers, so the one right after this would be 128. The other way of getting that is using our expression that we got over here. So that'll be x plus 2, so 126 plus 2. All right, let's try another one. So in this one, we're told to find 2 consecutive odd integers such that the sum of twice the lesser and 3 times the greater is 191. So this one's a little different, but the setup is going to be the same in the beginning. We want to figure out how to represent each of our integers. So again, since they're consecutive odd, those are numbers like 1 and 3. So if I call the first integer x, or let's define it this way, because they talk about the lesser and the greater integer. I'm going to go ahead and change that to not the first integer, but the lesser integer. And then our greater integer, just like before, to get from 1 to 3, we have to add 2. So it's going to be x plus 2. All right, so now this is a little bit trickier with the setup. It's not just the sum, it's the sum of twice the lesser. So twice the lesser, we call that x, so 2x, and 3 times the greater. Go ahead and erase this. So 3 times the greater means we're taking 3 times the greater, which is x plus 2. Make sure that's in parentheses. And we want the sum of that, so we're going to have the sum of 2x and 3 times x plus 2. And that should equal 191. This one's trickier just because of that kind of weird setup there for the equation. But now let's go ahead and distribute. So we still have 2x in the front, plus 3 times x is 3x. 3 times 2 is 6, equals 191. And now let's go ahead and combine like terms. So we get 5x plus 6 equals 191. Subtract 6 from both sides. So we get 5x equals 185. And then if we divide both sides by 5, this one you can go ahead and just do the long division off to the side if you want. So remember, 5 into 18 is 3. Just a long division recap. We'll see this again actually in chapter 5. So that's a 3, bring down the 5. 5 into 35 is 7. So we get x equals 37. And we want to find the 2 consecutive odd integers. So I'll just call these lesser integer. That was x, so that's 37. And then the greater integer, they're consecutive odd integers, so the next one has to be 39. But remember, the other way you can find this is by plugging it into our x plus 2. So it's 37 plus 2. All right, 2 last problems, and these ones are a little different. They're going to be more geometry based. Find the complement of an angle that measures 26. First thing we have to do is define what complement means. So complementary angles are angles that add up to 90 degrees. And then one other term that we'll see, we'll just go ahead and define it here, are supplementary angles. And these are going to add up to 180 degrees. And the way I kind of distinguish between the two is if we look at the beginning of complementary, the CO can be turned into a 90, and the supplementary can be turned into an 8. So you can remember that as the 180. All right, so now we want to find the complement of an angle that measures 26. Complementary means they add up to 90, so we have some 90-degree angle here. we know one of them is 26. So in order to find the other one, we want to go ahead and subtract it from 90. To define the variable here, though, I'm going to go ahead and put an X for that missing angle. And this is just going to be how I define them here. So we're going to go ahead and say that these two angles, X plus 26, should give us 90 because they're complementary. And then if we go ahead and subtract 26 from both sides, we get X equals, subtract 20, you get 70, subtract 6 more, you get 64. And so they're just asking for one of the angles because they already know what the other one is. So the other angle is going to be 64 degrees. And so if you just want to put 64 degrees, that's fine. Make sure you have the units. Or you can say the complement, because we were finding the complement, is 64 degrees. All right, so then the last one here is going to be really similar to that, but we're going to go ahead and talk about supplements. So the supplement, remember, means that they add to 180. And so 180 is a straight line. And we know that one of the angles is 92 degrees. And so our missing angle is X. If you don't want to do it by drawing it out, this is the same thing with the last one. You can always say that X equals the supplement because that's what we're looking for. All right, so again, we know that these two angles should add up to 180. So 92 plus X equals 180, or X plus 92. And then solving this, let's subtract 92. And so X is going to be equal to, subtract 90, you get 90. Subtract 2 more, we get 88. And so again, we can just say 88 degrees, or you can say the supplement is 88 degrees. But the big thing there is the units, the degree symbol. All right, so that's it for section 2.4. The next section is going to be some more word problems. These ones I'm not going to have a note outline for like I did for this one. They're more formula-based questions, so they're not going to be as long to write out. And then after that, we're going to be just about done with chapter 2. We'll have one last section on inequalities.